Hi folks, I'm sorry I'm not here today, but I do want to give you this video to help you finish the notes on line segments that we started the last class day. So I know that we got through part of it, classes got to different pieces, some students were just completely absent, and so what I'd like to do is go through all of the notes. I'm going to go through the front page a little bit faster than the two inside pages, simply because most class periods got to that, but I do want to give the information for those students who were absent. So this is going to end up going on page 17, and the TEKs are G.2a and G.2b. Those are in your divider. They end up being the first, the first and the third rows. So we're going to use, not the distance formula, but the midpoint formula in these notes to tell whether segments are congruent on the coordinate grid. And then what we learn in these notes helps us start right here to find the coordinates for a point that's halfway between two other points. So we begin talking about that in this set of notes. So our line segment here, I need to give it some points so that I can give it a name. We always name a line segment with two capital letters and a segment over it. If we're referencing the line, then we talk about two capital letters with the line over it with arrows. So if I write AB with a line with arrows, this means the line passing through points A and B. If I say AB with a bar on top, that represents the line segment. With endpoints A and B. And what I haven't seen a lot this year, and it would have been incorrect anyway, is people doing this for line and line segment AB. And I'm glad that I haven't seen that a lot, because what this means is neither the line nor the line segment. What it means is the distance from A to B. Distance from point A to point B. That's what it means. Okay, so we have line AB, that's a figure. We have line segment AB, that's a figure. We have AB, which is a distance, so that's a number. Okay, so I'm able to put like AB equals some number, and that would be correct. Okay, I could do that. So if I slide this down a little bit, what I'd like to find using this number line is the distance between these 2 points and between these 2 points. So typically what you would do if you're given a number line and all of these points that are really close together is you would count, right? How did you find these distances? Well, you're going to count. To go from B to D, that's 1, 2, 3, 4, 5. 5 units. So the distance from B to D is 5. The distance from A to B, 1, 2, 3. Well, that's a distance of 3. So AB equals 3. So the first kind of postulate that we're going to discuss in this line segment notes is the ruler postulate. And a ruler is just something you measure with, which is why it's called the ruler postulate, because it's about measuring a line segment. If you're given 2 points, point A and point B on the number line, the length of segment AB is AB without a bar on top, and the formula is the absolute value of little a minus little b, where little a is the coordinate for point A, so it's the number that point A is on, and little b is the coordinate for point B, so it's the number that point B is on. So in our first example, I'm trying to find the length from B to C. Well, in order to do that, I could count, absolutely, and I know that that distance is 7. But I also want to practice using my ruler postulate, which says that if I take the absolute value of one of my numbers and then subtract the other number, then I should be able to get my distance as well. And it doesn't matter if you use -12 or -5 first. When you subtract a negative, you're really adding. So -12 plus 5 is -7. And the absolute value of -7 is 7. So BC equals 7. The length from B to C equals 7. So pause your video, and I'd like for you to calculate the length of BC in this example. So pause your video, try it out. So you can double check. Of course, if you count, you're going to find that this distance is 1, 2, 3. But if you use your ruler postulate with whichever number first, it doesn't matter. You're going to find that the difference is either 3 or -3, and the absolute value of those is 3. So the distance from B to C is 3. Now, if you're given the task of finding a distance from 2 points in a word problem, like find the distance from Q to S, if the coordinate of Q is at -3 and the coordinate of S is at 21. So if I want to find the distance from Q to S, I'm going to find the absolute value of the difference. 21 minus -3. Minus a negative means we add. 21 plus 3 equals 24. So the the distance from Q to S is 24 units. Okay, so not too bad. This is the ruler postulate. So I'm going to open this up, and we're going to talk about the concept of betweenness. It seems kind of silly to talk about that because most people know what it means to be between, right? But it's kind of hard to describe to somebody else what it means to be between without using the word between. So if you want to try that, try to explain to somebody what it means to be between without using that word in your explanation. What it means to be between, for example, if point M is between points P and Q, that's true if and only if points P, Q, and M are collinear, and the distance from P to M plus the distance from M to Q equals the distance from P to Q. So let me show you what that means. I'm going to give myself a line segment. The endpoints are P and Q. Point M is only between P and Q if all 3 points are collinear, so point M needs to be somewhere on that line segment. And it says the distance from P to M plus the distance from M to Q must equal the whole distance from P to Q. So now looking at a picture of that, it kind of makes sense, right? This length plus this length must equal the whole length. A part plus a part must equal a whole. So that leads us to something called the segment addition postulate. Again, it is a postulate. Remember, a postulate is something we accept to be true without proof. It's something that we could use to justify an answer. So if 3 points A, B, and C are collinear, and point B is between A and C, kind of like point M is between points P and Q, then we can say that the distance from A to B plus the distance from B to C equals the whole distance from A to C. So if you refer to that diagram, it means the same thing. A part plus the other part equals the whole number, the whole distance. So let's look at example 3, and I think that this is where we kind of start getting into the area where class periods didn't get to the notes. So I'll slow down a little bit, but I do want to talk about the segment addition postulate with example 3. It says if S is between points D and T, so here's points D and T, point S is somewhere between. Okay, I don't want to put it right in the middle because I don't know if it's right in the middle, but it's somewhere between. Okay, I'm supposed to find the length of DS and the length of ST. And so to remind myself that those are the things I'm finding, I'm going to put those over in the corner. I'm going to box them so I know what it is I'm finding. Okay, the segment addition postulate states that part of the whole segment plus the other part of the whole segment should equal the length of the whole segment. So DS plus ST should equal DT, right? DS plus ST should equal DT. So I'm going to take the pieces that I've been supplied with and I'm going to insert them into my segment addition postulate. So the distance from D to S is 2x minus 8. Oops, 2x, misspell sick. 2x minus 8. Okay. The distance from S to T is 3x plus 12. and it should equal the distance from D to T, which we're given as 60. Now, the only way that I'm going to figure out what ds and st are is if I have this x value. So that's what I'm looking for. I'm going to combine my like terms. 2x and 3x is 5x. Negative 8 plus 12 is plus 4, and it equals 60. If I subtract 4 from both sides, I have 5x equals 56. And if I divide by 5 on both sides, I get x equals 56 over 5. Which is not the prettiest answer, but it's not a wrong answer. It is also neither the length from D to S or S to T. I have to take this and use it to get those answers. So I'm going to take 56 over 5, and I'm going to substitute it here, and I'm going to substitute it here. So ds equals 2 times 56 over 5. It's minus 8, but if I know that I'm subtracting from something with a denominator of 5, I need minus 8 to be minus something over 5. So in order to get that new numerator, I need to multiply 8 by 5, and this is really minus 40 over 5. It means the same thing as minus 8, but it's in a way that I can actually do the mathematics. So ds equals 2 times 56 is 112 over 5. And I subtract 40 over 5. And when I do subtraction with fractions, I keep my denominator and I just subtract the numerators. 112 minus 40 is 72. So that's my distance from D to S, 72 fifths. Weird, but correct. Pause your video and substitute your x value here to gain the value of the length of ST. Pause your video. So the length from S to T is 3 times x plus 12. 12 was rewritten so that it has a denominator of 5. So 12 times 5 is 60, my new numerator. 3 times 56 over 5 is 168 over 5. And if I add my numerators, the distance from S to T is 228 fifths. So I'm going to move to example 3b. Move up a little bit. Same idea. If E is between points D and F, so here's D, here's F, E is somewhere between those two, so it's collinear with points D and F. And if it's between, that also means that the distance from D to E plus the distance from E to F should equal the full distance from D to F. And what I need to do is I need to find the distance from D to F. Okay. So I'm going to insert the values that they gave me. DE is 3x minus 1. EF is 13. And DF is 6x. So I'm going to combine my like terms on one side. Negative 1 plus 13 is 12. I need to put my x's on the same side, so I'm going to subtract 3x from both sides. And if I divide by 3, I get x equals 4. Well, 4 is not the distance from D to F. The distance from D to F is 6 times 4. So DF is 24 units long. Okay, so that's what betweenness means. It gives rise to the segment addition postulate. And now I'm going to move over to my last side of the notes. And it starts out with another few definitions. So two segments with the same length are called congruent. And the symbol for congruent looks like this. It looks like an equal sign with a little squiggle on top. Okay, so it's kind of equal, but it's not really equal because equality is meant for numbers. Figures are said to be congruent if they are the same, but numbers and values are said to be equal. So it's very important that we use the right thing for the right thing, if that makes sense. If we have a figure and we're talking about like a shape, like lines or line segments or a polygon or things like that. If we're talking about like pictures and they're the same size, same shape, that's congruent. But if we're talking about numbers, like the length from D to F and 24, we say those are equal because they're numbers, they're values. Okay? The midpoint, this is where we start talking about what was in our unit divider for G.2a and G.2b. The midpoint M of segment AB is the point that bisects or divides the segment into two congruent segments. So let's break apart this word, since we've broken apart so many words in geometry to see what they mean. The prefix bi means two. Sect is either to cut, or it means sections, so maybe cut into sections. And the midpoint bisects or divides the segment into two congruent segments. So here's segment AB. The midpoint M is a point right in the middle. And that midpoint M bisects the whole segment AB into two congruent segments. If you're going to mark segments as being congruent, I know that we talked about how this is the congruency sign, but to show it in a figure, you put little tick marks. Segment AM is congruent to segment MB. So you could say segment AM is congruent to segment MB. The segments are congruent. Their lengths are equal. Now, piggybacking off of that definition, and I know this is a tiny blank for this phrase, but a segment bisector, segment, write small, bisector, is exactly what it sounds like. It's going to bisect a segment. And it can be a ray, it can be a segment itself, it could be a line that intersects a segment right in the middle, so right at the midpoint. So we have two examples of midpoint, and then you're going to get your assignment. So an example 4, it says use the midpoint to find the lengths. So B is the midpoint of segment AC. So let me draw that. Here's segment AC. B is the midpoint, so by definition, it bisects or divides the segment into two congruent segments. It's right in the middle. So segment AB is congruent to segment BC. It says segment AB's length is 5x and segment BC's length is 3x plus 4. I need to find all of these. I'm responsible for them all. So the length from A to B, the length from B to C, and the length from A to C. Okay. So if point B is the midpoint, that means segment AB has the same length as segment BC. Right? That's what it means. The two segments are congruent, so their lengths must be equal. Well, segment AB is 5x, and segment BC is 3x plus 4. So if I try to solve for x, I need to move the x's on the same side, so I would move this 3x over here. 5x minus 3x is 2x. And I would divide by 2, so I would have x equals 2. So let's find all of the pieces. AB is 5 times x, and x is 2. So AB must be 10. Now, if AB is 10 and B is the midpoint, what does BC have to be? Well, it has to be 10, and it would be a good idea to check and make sure that BC is 10. So 3 times 5 is Oh no, not 5. Why not 5? Because 5's not even in the problem. What is the x value? 2. So 3 times 2 is 6. 6 plus 4 is 10. So we're correct. Now I need the length from A to C, and that little equation here is not given for the length from A to C. But the segment addition postulate says if AB's length is 10 and BC's length is 10, then the distance from A to C must be 10 plus 10. So this must be 20. So what I'd like for you to do is pause your video, review example 4A and attempt example 4B. Draw a picture, draw a diagram, and then write out your statement based on the information that's given to you. So try example 4B. Pause your video. So point D is the midpoint of segment EF, meaning it's right in the middle. Segment ED is congruent to segment DF, so the length from E to D is equal to the length from D to F. ED's length is 4x plus 6. DF's length is 7x minus 9. I need to solve for x in order to substitute them here and get those lengths. So I'm going to move 4x over here. If I move 4x over here, I have 3x. If I move negative 9 over here, I have 15. And if I divide by 3, I get 5 for my x value. Substituting 5 for x, 4 times 5 is 20, plus 6 is 26. If the length from E to D is 26, then the length from D to F should also be 26, and you can check that it is. And then the full length of segment EF should be 26 plus 26, which is 52 units long. So now, the remainder of the class period needs to be used to work on the assignment associated with these line segments. Please glue these notes into page 17 of your notebook. Y'all have a great day. Bye, guys.